Hello, in this video we're going to begin our basic MMORPG Combat implementation. This should be an interesting one. This is using our Unreal Engine client, interacting with our Java custom server. Yeah, we're going to be essentially sending requests to begin combat for our character. We'll essentially be requesting the server to start attacking things. And the actual combat loops and things like that will be happening on the server side to prevent hacking and things like that. And we'll be sending information to the client in order to, for example, start animations and, update the stats when damage is taken and things like that. So that's what we're going to be covering today. In terms of the architecture of what we're following, I've covered those in the past. So I'll link those in the description. So I've covered some material on what it is that we're going to be implementing. And in terms of the source code, the Java server code can be found on GitHub. So that's publicly available. So in this post, you'll be able to see all of the steps I needed to take in Unreal Engine to replicate what I'm going to be showing shortly. And do bear in mind that the implementations will be changing, right? So it simply hits a checkpoint. So that's why I wanted to showcase what I've done so far. But obviously, I'll keep working at this combat implementation because you'll be able to see shortly that, there's not really much validations happening right now. So obviously, we'll need to be changing some of that implementation in the near future. So you will see all of that changing. So let's begin with a quick demo and then we'll get straight into code. Okay, so the first thing I want to show is that the net mode is set to play standalone. So I'm going to be interacting with the Java server, but I will be spawning a UE server, which will be controlling the mobs in the game as well. So you'll be able to see that when I log in, there's no mobs around me. I'll just open this up as well. You can see that once this is up and running, I'm going to have a couple of mobs spawn, and that's my UE server controlling those monsters, right? So I'll be able to show the post where we've achieved that. The other thing I want to show as well, so I've got a weapon equipped, and I'm also highlighting some of the stats here. So you'll be able to see that with the weapon equipped, my weapon speed is 2.3 seconds. And I also have another parameter called attack speed, which I've set it so that if my attack speed is 100, I attack twice as fast, right? So there's a couple of other parameters like the weapon damage and the physical amplification, which I'm also taking into account for now. The main thing that I want to show now is that when I click a button T, it will start attacking. So you can see as soon as I click this button, I go ahead and attack one of the monsters randomly that's around me. Okay, so that's basically what we've got implemented right now. And after the monster dies, you'll be able to see that a new one should spawn. So this is integrated with my spawner system. You get some health again. That's synchronized with the Java server. And again, I'm just able to start attacking the next mob. The other cool thing is that, as you can see, I can run around and I'm swinging my weapon, still doing damage. So there's plenty of things to do still. So for example, I need to do validations to make sure that I'm looking at the monster. I'm close enough to the monster in order to attack them. I should also implement some AI on the monster to, attack back, all of that good stuff. But you can see that this is starting to take shape now. The other thing is, for instance, you'll be able to see that my attack swing comes slightly before the actual damage takes place. So the Java server tells me to swing my weapon just slightly before the attack damage takes place. So I think I set it to 100 milliseconds before. And the server itself doesn't even know whether you will hit, you will miss, what kind of things will happen. But as you would expect, before you take damage, you do want to start swinging your sword. So that's kind of what we've got implemented at the moment. So let's get straight into the code. Okay, so perhaps I'll get started with the input actions. So like I said, in my demo, I've clicked the button T, and that would go ahead and attack a random mob around me. So I'll be changing this logic to attack the nearest mob, right? So often in games, you do have the ability to just click a button and attack the nearest target, for instance, right? So I will be changing it to that. At the moment, it's just set to attack a random mob. But in order to create it, so I've basically created these little blueprints. You'll be able to create these input actions. So right click under input, you have input action, and inside them, they're pretty simple. In fact, this one I think is kept as default. So consume input is enabled and the value type is digital bool. And then you also want to create your action bar actions, which is basically your, what is it called? Input mapping context. So this is what we're going to be mapping inside our blueprints. Okay, so once you've created that, in here, you'll be able to map it to the keys that you like. So for instance, for my attack input action, I want to map it to the T character. Okay, so let's see how we map that into our blueprints. So what I've done is I've created a new folder, so for the action bars, and I'm creating a new component called actions component. So in order to create that, just create a new blueprint, and in here you'll want to select it as actor component. So that's how we create one of those. And inside there, we basically want to register these inputs. Okay, so what I do is I get my player controller and I get the enhanced input local player subsystem, and then I add the mapping context. So inside here, you can see that I've linked the mapping context to be that action bar actions. Okay, so that's how we will link our attack actions to our character. So basically, we've added them onto this actions component, and our player character blueprint will now have this actions component added to it. Okay, so the reason why I create a whole component for it is that in the future I'll also add a lot more actions. So for example, if you want to harvest some materials, you know, if you're doing crafting and things like that, I'll add them there. Perhaps some random animations like waving your hand or whatever, I'll add them to the actions component as well. So it's not going to be just for combat, it will be for just random actions that your character can effectively do. So we've just shown that we've registered these actions inputs, but actually, so we registered them on event begin play. So basically, when this component gets added to the character blueprint, this will always get called whenever your blueprint is instantiated. And you can see that the first thing that we do is register those action inputs. So we do two more things. We basically grab the player reference. This is just to put in the variable so that it's a bit easier to use, but you know, it's just the owner of this component, which at the moment I'm using as a player character blueprint. And we also grab the player socket integration component, which is just responsible for all server communications. So it contains a lot of information like the monsters nearby and things like that. Okay, so now that we've registered those inputs, we can start utilizing them. So for example, I know that my enhanced input action is called IA attack, so I'm able to find it just by typing it in. Okay, so that's how you get access to that event. So all I need to do is then just drag it out. So from started, I can start implementing the things I want to do when I click that button. Okay. So as mentioned, from my socket integration component, I'm able to extract things like nearby mobs data. So the component, the socket integration component, is responsible for synchronizing the nearby mobs to the player. And all I'm doing is just first of all checking, is it empty? And if it's not empty, I just grab the first element in that array. Okay, so I'll be changing this logic to potentially grab the nearest monster, but at the moment it's simply grabbing the first element, which is why it's kind of random, right? Okay, so with that element, I'm going to send a combat request to my Java server. So the payload here, I'm trying to make it sort of backwards compatible. I'm not actually utilizing the location or the skill ID. So in the near future, I'm not just going to have combat using my right click, right? So I'm gonna introduce skills. They'll have IDs. I may need location where you're targeting the skill, for instance. And in terms of targets, again, it might not be singular, right? So I'm only supporting single targets at the moment. But the payload will allow me to make an array just so that it's backwards compatible, okay? So in terms of the message payload, the update type has to be try attack. So I'm just telling the server that this message is trying to attack a monster, and here are my targets, right? So this list will contain one ID for the monster. So that's kind of what's happening right now. I just convert that to a JSON, and I'm sending this message to my server. So the server itself is then going to be processing that message and sending me some responses. Okay, so now that we've requested the server to start attacking a mob, we should get some responses back. So now we go back to our player socket integration, which deals with all of the communications. So I had this function called process message received, and I described it as the post office of messages, right? Because I receive a message from the server and it contains the message type, and based on that message type, I route it to the relevant place for processing. So this function is starting to get a little bit busy, so I'm going to be splitting it into domains, right? So you can see I've now created a new function which will deal with processing combat related messages. So at the moment it'll just have this one because I just have the one message type in here for now, but it will expand, right? So the first thing that I'm going to do is process initiate attack. So this is a response from the server to tell my client that it's ready to start swinging the weapon. So it doesn't mean that damage has been taken yet or anything like that. It just tells my client to start swinging my weapon, and you know, an update to the stats will come soon, like for instance damage. Okay, so that's where I get myself the player character blueprint. So that's the owner of this component, and I'm telling it to start swinging the weapon. Okay, so the combat request, so this is the response from the server, will contain an item instance ID. So the item instance ID is the item that you have equipped that you're currently swinging. So it could be a weapon that's in your main hand, it could be a weapon that's in your offhand, and it could be a sword, it could be a bow, it doesn't matter. But depending on the weapon type, your animations are different, which is why the animations are sort of sourced from the item rather than just generically within your character. So basically, you have a list or a map rather of equipped items, and this map, basically the key is your item instance ID. So I'm able to get this melee weapon, at the moment it's melee weapon, but I'll need to refactor it as a base weapon, and I'm asking that weapon to start animating the attack. Okay, so let's go inside here and see what that does. So these weapon blueprints are pretty interesting, and they've been recently created. So I'll reference the link in the description about how they work. But ultimately, they're just a pure object which contain some useful information to process. So for example, this base melee weapon contains some animations depending on where it's equipped. So for example, if the weapon is equipped in your main hand, you could be using these animations. If it's equipped to your offhand, it should use these two-hand animations can be found here. So this base class isn't aware of the actual item instance, so it's not sure which one is required, but depending on the overrides for these booleans, for instance, one-handed or equipped in main hand, I can determine which animations I need to use. So that's what's happening in this start animating attack, right? So it's checking, is this item, is this weapon equipped in one hand? If it's true, is it equipped in my main hand? And again, if that's true, it's saying, okay, the animations to use are these main hand animations. So you can see I haven't actually populated the other ones because I only have the one type of sword for now, right? But you can see how I'm going to scale it for my other types, right? So I'm just going to be populating the anims to use to the other two variables depending on those parameters. Okay, so now that I've determined which animations I need to use, which is effectively these main hand animations, so you can see I've got 3 of those in here. I grab a random integer, so you can see animations to use, the length of that is 3. So I grab a random integer from effectively 0 to 2, but up to 3 total. And I grab one of those to use and play the animation montage onto the item owner. So you can see that this is going to be generic. So it's not just for your character, it's also for the proxies representing other players. I'm able to reuse these blueprints on those as well. So this is how I'm going to be playing the attack animations for the players, essentially. There is one thing I wanted to highlight with these attack animations as well. So basically, this is the montages that are playing, and you can see that the feet are also affected by these montages. This is something I wanted to avoid so that I can continue walking around while also swinging my sword, right? So in order to work around that, I needed to do some attack animations blending. So this is also covered in the post, so do check that out. And there's also a really cool video on this. So this is basically where I got the details for how to do it myself. So do check that out. It does go through the details, which are really good. But ultimately, I'll just show you very briefly how you're able to sort that out. So if you open up your player character and then you go onto your mesh, you'll be able to find the animation classes which are used on your characters. So if you double click those, this is what you'll need to basically change here. So by default, this default state machine is connected to the output pose or something along those lines. And what we want to do is essentially create this cached pose. Okay, so you'll want to use that cached pose and mix it with this layered blend per bone. So this will go into your input A. And then again, you'll use this walking animation cached pose, and you want to do this slot default. And what this does, you can see that it plays animations from code using the animation montage. So that will effectively get connected here. So this layered blend per bone is able to tell us where to play the animations from. So for example, from above the spine, we'll be playing one set of animations, and below it, we'll be playing another. And in terms of the bone name, so you can see here, it's called spine_01. So how do you get that? You get that from the skeleton. So for example, this is how I'm able to open up the skeleton. And if I basically navigate down, I was just basically looking for where my spine begins. So this looks pretty good. It's around the middle of the body. And this is called spine_01. So I believe this is case sensitive. So you'll have to copy that exactly and type it in here. So again, if you're not 100% sure, do check that tutorial because it goes into quite a lot of details and it's very good. So yeah, do check that out. Okay, so that's how we will blend our animations and continue running while also swinging our weapon. Okay, now that we've played our weapon montage, we can start looking into the next expected message received. So let's go to message received, which will be the stats update. So basically, when we start swinging our weapon, nothing happens, but then after a while, we expect to either do some damage, miss, or whatever, and our current HP will effectively go down, right? So because the current HP goes down, this is an inherent stats update, so that's why it will get included into this message over here. So let's go inside here and see what changes we have. So this component looks a little bit more complicated now, and the reason is because this stats component can now exist inside our player character. It can be a mob, or it could be the nearby proxy characters as well. So we're not sure which actor it belongs to, so that's what we're trying to find in this function right now. So from the message response, we have this stats update, and inside our stats, we have the actor ID. So using that actor ID, we check, is this equal to our player name? If it is, that means that the stats update is about our player that we're currently playing. If it's not equal to the player, we're going to check whether it exists inside the nearby mobs data. So we basically check inside this map, does an actor ID exist inside this map? If it does, that means that that mob is having a stat update. And if it's not a mob, then it should be a nearby player data, which is the proxies nearby, representing other players. So in this case, it's basically going to be inside here, so nearby mobs data. We check, we find the actor ID with that ID. And from the mobs data, we also are able to extract the stats component. So bear in mind, the actual function itself is the exact same one. So process stats update, but the stats component, the reference to that stats component is different depending on who it belongs to. Okay, so let's go inside the process stats update and see what that does. Okay, so inside the process stats update, I do a quick validation for the actor ID just to make sure that it's equal to what's in the stats update. This is a little bit redundant now, now that I've added the check in the previous step. And the rest of this component looks mainly the same as it was in the past. And again, I can reference that link where basically we merge the base stats, which is like your strength, dexterity, stamina, etc. So that's not affected here. We used to go ahead and merge the derived stats straight away, which is your max HP, current HP, NP, etc. So before we do that, we want to process the damage taken, right? Because basically some of the derived stats include the current HP, and if the current HP change, that means you've either experienced some damage or some healing. So that's what's happening here. Now, do bear in mind, I will be changing this function. I just wanted to implement something pretty basic so that I can do this demo. But I'll very likely be adding an additional map to sort of portray the damage taken, right? So the backend actually supports a map of damage taken, which would be, for example, physical damage, which could be slashing damage, bludgeoning damage, etc. It could be magical damage like fire damage, poison damage, etc. And I may want to display it using different colors in the screen. So using this method, I'm not going to be able to do that, but it is a pretty simple way to sort of demonstrate damage taken, right? So again, I received some stats, and if it contains the current HP payload, that means that my current HP had changed, which means I've either received healing or damage. So then all I need to do essentially is grab the previous state of my HP and subtract the updated value for the current HP, and that's basically how I'm able to evaluate whether it's damage or healing. And what I do is I then play an animation on a widget to basically show that damage taken. So let's basically have a look at that now. So I went ahead and created a new widget to display my damage. So this will be damage taken by mobs or players. You can see the component itself, this widget is very simple at the moment. It just has a size box and this text box for damage. Inside the damage text box, my text is linked to the damage variable. So you can see inside the graph, I've created a new variable, which is an integer type. It's called damage. And you can see that it's instance editable, so that I'm able to edit it in other blueprints as well, which is what I'll be doing. And a neat little thing that I did was also add some animations. So in order to see the animations window, you click window and click animations. So you'll bring this up. You'll be able to create a new animation over here. And what I'm doing is modifying the opacity of the text inside this text box. So in order to do that, just move this little stick around. I'm not sure what it's called. So set your opacity to 0 and then add a keyframe, which will make the opacity when you're playing this animation 0 at time 0. Okay, so cancel it again. Then at time 1, again, you'll want to just add another keyframe for this property, again making this opacity 0 at time 1, and then at time 0.5 you'll want to change this opacity to 1. Okay, so what that means is when you play this animation, the opacity will be 0, it goes to 1 at t 0.5, and then it goes back to 0 at t1. Okay, so the steps for this were actually included in a different video, so you can see that there's the section covering the damage widget display, and there was a video including the tutorial for this, so it was covered by this one over here. So another great tutorial for how to add that animation to your damage widget, so check that out as well if you're having issues with doing this part. So in terms of the graph, you'll be able to see that there's literally nothing implemented here. So the damage is simply displayed into the text box, and it's linked directly inside this damage component. Okay, so then inside your base actor component or your mob components, so I'm going to be refactoring my mobs and players to basically go from the same parent class. That's not done yet, so that's why you'll be able to see this damage widget display exist inside my mob base actor for now, but I will be creating a common base class later. In order to add this widget, so inside your sort of character blueprint or your actor blueprint, you'll be able to add this widget component. Okay, so that's how you get this up. You'll be able to call it whatever you like, so mine is called damage widget display, and you'll also be able to specify the widget class, and this is the widget class that we just looked at, right, the damage widget. You'll also be able to reposition it as you like, so you can see that the skeletal mesh is not actually displayed inside this base actor because that's defined through other classes, but you can see that it's basically positioned to be above the actor. So we'll be able to potentially override it depending on the mobs that we have, but at the moment it's like my mobs are basically the same size and things, so that's why it can exist here. So that's how we define the widget, and that's how we add it to our actors. So let's have a look at how we play it. So we play it back in our stats component, right? So basically, remember when we evaluated the damage that we take out? So you can see here that we grab the owner, and from the owner, we basically cast it to the correct class. So this part will be changing, right? So the moment I cast it to the mob base actor, where I've realized that I haven't actually created a common base class between my character and the mob. So I will need that. They'll need to share the stats component, and they'll also share this damage widget display. So at the moment, I'm casting it to the mob base actor. I extract my damage widget display. So I extract the widget from there, which is the damage widget. And then I set the damage on that damage widget, which will update the text value, and then I play the animation. Okay, so when I click play animation, remember the opacity begins at 0, it goes to 1 at t0.5, and it goes back to 0 at t equals 1. So that's what this will do. Okay, so the other thing that I needed to do is also make sure that this widget is pointing to the player's camera, right? Because it's sort of a 2D object, and it could be basically facing whichever way the mob is looking at, but I need it to basically look into the player's camera so that you can always see that damage. So the way I did that is inside the mob base actor, which will be basically the base actor class. I also call rotate damage widget on the event tick. Now the other thing that I do here is just make sure that the pop-up animation is actually playing, just so that I'm not constantly just doing some rotations. So I grab the damage widget display, right? So I grab this component, I get the damage widget, I check, is the pop-up animation playing? And if it is, then I want to set the world rotation of this damage widget display to basically face the player's camera. So that's what this is doing. It's just making sure that that widget is facing the player's camera. And that's basically it. So I suppose the other thing to mention is that inside the process message received, when the health of the mob goes down, the Java server will actually delete that instance of the mob, and it will also trigger this remove mobs functionality, which will go ahead and destroy the actors. It's also referenced to the server. So the server contains this list actors to sync, and it will also destroy that inside the Unreal Engine server instance. And it's connected to the AI spawner system, which basically when you destroy that actor, there's some configuration settings that I can set to make it respawn. And again, it will just simply respawn that, push that data information to the Java server, which will, synchronize it up and bring it into this client as well. So it's a little bit complicated, but it's kind of neat with the way it works, and it should be quite scalable. So perhaps again, we'll just finish off with a quick demo where I just reference a couple of the things that we did. Again, so I'll click play, so you'll be able to see that I'm spawning the Unreal Engine server in the background. This one is playing in standalone. So when I click play here, I'm just going to be waiting for the Unreal Engine server to spawn, which will be effectively controlling these mobs. As you saw, there was like some HP that popped up in front of those mobs. At the moment, I left that in so that you can see that when the stats get updated, some HP gets allocated to these mobs. I'll remove that in the future, but it was pretty good for debugging purposes. When I click the button T, I'm processing the input actions to start combat. You can see that I have 3 different animations to play. It will play them randomly. It will play them until the mob is dead. When the mob is dead, we destroy that actor. Inside the spawner system, it basically recognizes that the actor was destroyed. It waits a certain amount of time, which is configurable. It then spawns another actor, and I'm able to begin the next attack loop. Okay, so when I do damage, you can see that even when I'm rotating the camera, that damage is displayed to my camera, which is what we were just working on earlier. And yeah, so that's basically the demo at this point. So some of the next things that I'll be doing is a bit of cleanup, to be honest. So I want to make sure that I have the common base files for the common blueprints between my mobs and my characters. So they'll share the stats component, for example, the damage bar, things like that. I'll also want to add some validations. So for example, I can only attack when I'm next to the monster. And this validation will need to happen both inside the Unreal Engine and the Java server. And yeah, so quite a few things to do there, to be honest. But it is making good progress. So yeah, hopefully it will look even more mature soon. But that's it for this one. Thanks, and see you next time. Bye.